Hello viewers, in this video I would like to discuss about different types of modes of operation. We know that symmetric encryption message block size is M block and messages are not M size. Actually, it is longer than that. If we want to transmit more than 128-bit message, then we use modes of operation. It can be any size of message for encryption. It is called symmetric encryption mode. For cryptographic process, there are different kind of modes of operation: electronic codebook, cipher, blockchain, cipher feedback mode, output feedback mode, and counter mode. The very first one is electronic codebook. In this case, we have the same size of plain text and same size of cipher text block, and the input is in block. Large message or plain text is divided into 128-bit block. Equal plain text block will be have the equal cipher text block. It is not recommended because if any of the block of cipher text is modified or missing, then the reflection will come back to the plain text while we will decrypt it, and the plain text will not be predictable. Now there is another types of disadvantages of it. It is like if we swap, then it is problem. Means I have a cipher text. You can see if we swap the cipher text block from block 1 to block 2, then the same reflection will come to the plain text, and then the if ciphertext block is omitted, then the plain text will be missing. It is easy to implement it. That is the advantages. Now we have another type of mode of operation that is called cipher blockchaining. In the cipher blockchaining, we have an initial vector, and we have a one encryption depends on the previous block. Decryption operation is just the mirror of encryption. You can see that we have a plain text XOR with the initial vector, and then we get a calculation, and that is the ciphertext, and S is here symmetric encryption. Now in this after the calculation we take feedback, we give feedback one back to the next plain text block, and we do encryption, and then this is the cipher text block, and so on. So once it is done, the cipher text, if we want to make again back to the plain text, we will see that decryption operation is just a mirror of encryption. When the first block has no previous block, we use that initial vector IB. Okay, some plain text will have different cipher block. Same plain text will have the different cipher block. Message can be decrypted from any part but not the encryption. In this case, the message can be decrypted from any part but not the encryption. Now, in this case, the XOR now depends on the previous block, so there will be no longer duplicate or repeated cipher text. And disadvantages is if one block is missing, then it will affect on two blocks. That means that the block and the next block will be affected, but the block after that will be decrypted as it is on the cipher text block. So the plain text will be like that. There will be no more change. So the question is about cipher feedback mode. Here, instead of transmitting the total 128 bit, we use here I bit of block, instead of just a minute, instead of okay. So in this cipher feedback mode, we use that not the 128-bit block. If we want to encrypt I bit, then we use the cipher feedback mode, and blocks are divided into individual I bit, and we use a pseudo random as key for the encryption, and this I bit later used with the encryption with the I bit plain text, and that is used, that is we get the I bit cipher text block. This I bit cipher text block we get, and and we make a left shift register of I bit, and the rest we use for the letter. So block is divided when we want to encrypt individual I bits. We use encryption scheme to generate something like OTP. You know that one-time pad is totally random. So one key in this case of cipher feedback mode, we use a pseudo random key, that is S. We want to transmit all 128 bit, but in a small part of I bit, means we don't want to transmit all 128 bit, but just some I bit, and so we do the XOR of random sequence of I bits of plain text to obtain I bit longer cipher text. With them, then do I bit shift, and again we do the encryption of next I bit. We can observe that in decryption method we again use the same encryption key instead of decryption key, and this is because we want to have the same XOR operation on the I bits. So you can see that here the first one is used for the encryption, and the second one is used for, second part is used for the decryption. So here in encryption we use symmetric key as pseudo random, that is also used for the same decryption method for the same key, and we obtain the same I bit plain text key. Here in the decryption we use this I bit cipher text block for the next I bit also. Another type of encryption is output feedback mode. Here, acting bit sequence does not depend on the encryption method. Output feedback mode is not recommended because it is vulnerable to the attacker, and it is worse method than the cipher feedback mode, because if output feedback mode used twice with the same pseudo random key, then if someone has the block I bit of the shift register, then attacker can get the next result and so on. So you can see the picture here. We are not using the encrypted bit or the plain text anymore, not the XOR operation. We just use the previous, before the XOR, the I bit result we are using for the next bit, and so on. In the decryption method also we are using the same process. Here is the main problem of it is like that's why it is vulnerable, because of I bit. If someone has the block of I bit shift register, then attacker can get the next result that are same. Now we have another type of mode, that is called counter mode. It is just like same the output feedback mode, but no feedback, and it has a counter that is increasing depending on the block. This counter are encrypted and XOR with the plain text. We use this encryption mechanism with the session key for encryption key. So this is the counter mode operation. You can see here